Okay, so hi guys. So I'm gonna make a really quick video over how to do half-angle identities. So yeah, so basically we want to find the sine of 15 degrees, the cosine of 15 degrees, and the tan of 15 degrees, and using half-angle identities. So I'm gonna write down the half-angle identities. So let's see. So sorry guys, I'm just looking them up. So, so really, um, in reality, so we know that the half-angle identities are sine of pi over 2, or I'm sorry, sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2, and then cosine of theta over 2 equals plus or minus the square root of 1 plus cosine of theta over 2, and then tan of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. Okay, so I drew this quadrant because we have to know exactly where 15 degrees would be, right? So in reality, we want to know, well, yeah, we want to know where would cosine of theta over 2 be, right? So um so really, or sine of theta, cosine of theta, and tan theta, so they're all positive, so that means we're going to have positive square roots. So if we write it down, we know that sine of 15 degrees equals sine of 30 over 2. So that's, yes, that's sine of 15 degrees. So now sine of 30 over 2, we can simplify it as the positive square root because it's positive in the cosine direction, or in the sine direction. In terms of sine, we can say 1 minus cosine of 30 all over 2, right? So 30 degrees is equal to, it's going to be 30 pi over 180. This is 3 pi over 18, which is about pi over 6. So it corresponds to the coordinate square root of 3 over 2 comma 1/2. This is why you have to know your unit circle, guys. It's really important that you know it. On the unit circle, if I draw it really quick, it gives me, so here's the middle, and it gives me kind of like this, right? It's pi over 3, and this is 1/2 square root of 3 over 2, and then it keeps going, so it's like pi over 4. This is square root of 2 over 2 comma square root of 2 over 2, and then this one is, actually, give me a second, so it's pi over 3 is actually right here. I'm drawing it really, like, crappy. Give me a second, guys, actually. So, this is a unit circle. So, you see at pi over 3, or sorry, at pi over 6, it's square root of 3 over 2 comma 1/2. Right here. So, there is where basically it's cosine comma sine. So they're both basically in quadrant 1, they're all positive. So that's why it corresponds to that coordinate. So the cosine of 30 degrees is actually positive, and the sine of 30 degrees is positive, and the tangent of 30 degrees is positive. So that means that the cosine of 30 degrees is actually the x value of the coordinate that corresponds to pi over 6, which is square root of 3 over 2. So that's for the cosine. Right? So now we can say this is equal to the positive square root of 1 minus the square root of 3 over 2 all over 2. This is equal to the square root of 2 over 2 minus square root of 3 over 2 all over 2. Let me actually... so that you guys can understand what I'm writing. So it's 2 over 2 minus square root of 3 over 2 all over 2. Right? So then this equals 2 minus square root of 3 over 2 over 2. And it's the square root. This becomes equal to 2 minus square root of 3 over 2 divided by 2, which becomes 2 minus square root of 3 over 2 times 1/2, which equals 2 minus square root of 3 all over 4. And it's the square root. So then this becomes the square root of 2 minus the square root of 3 all over 2. And it's the positive, right? So that is what cosine, or sorry, that is what sine of 15 degrees would be. You can use a calculator and approximate it. You don't have to, though. Not in this case, unless they ask you. Just make sure you round it to the right, to the correct decimal places. So that is for sine of 30 over 2. Now what about the cosine of 30 over 2, right? The cosine of 30 over 2 is going to be equal to plus or minus, so it's going to be positive because cosine is positive in quadrant 1. So it's positive 1 minus, it's going to be 1 minus, or sorry, 1 plus cosine of theta. So 1 plus cosine of 30 all over 2, right? So then this becomes the square root of 1 plus, and the cosine of 30, if we look back at our unit circle, the cosine of 30 is, give me a second, guys. Okay, so basically, it's 1 plus cosine of 30, and then, all over 2, and so the cosine of 30, we look back at our unit circle, the cosine of 30 is the x value, so it's going to be this one right here, the square root of 3 over 2. So we're going to put the square root of 3 over 2 over 2. This becomes the square root of the square root of 3, or actually it's going to be 2 over 2. Sorry guys, give me a second. So it's going to be 2 over 2. The reason why I do that is because they have to have the same denominator for this. If you don't know how to add fractions, the best way that I can tell you how to do this, when I have 1 plus square root of 3 over 2, just say 1 over 1 plus square root of 3 over 2, and then multiply it by the denominator on top and bottom, and then you have 2 over 2 plus square root of 3 over 2. That's how I got that. Because I know some people can't do it in their heads, so that's why, well, yeah. So then, this becomes equal to, and let me make more space. So this becomes equal to 2 plus square root of 3 over 2 over 2. So this is all square rooted. This is equal to 2 plus square root of 3 over 2 divided by 2, which equals 2 plus square root of 3 over 2 times 1/2. This becomes 2 plus square root of 3 over 4, and this is actually square rooted, so then this becomes, the square root of 2 plus square root of 3 over 2, because the bottom is square rooted. So this is what cosine of not pi over 2, of theta over 2 would be when it's, you know, of cosine of 15 would be. So this is what cosine of 15 would be. For any of these guys, let me know if I'm wrong. I'm doing these without having any kind of, like, obviously I know the method, I know how to do the method and stuff, but I don't have like a proper answer key or anything like that to verify that I did it right. So if I make any mistakes with any of my answers, let me know. Tan of theta over 2. So tan of theta over 2 is tan of 30 over 2. This is equal to tan, so this is equal to, actually, it's going to be equal to the positive square root of 1, I think it's 1 plus cosine, or I'm sorry, 1 minus cosine of theta over 1 plus cosine theta. So 1 minus cosine of 30 over 1 plus cosine of 30. We already know what the cosine of 30 is. Cosine of 30 is square root of 3 over 2, so it's going to be 1 minus square root of 3 over 2 over 1 plus square root of 3 over 2. And then this becomes the square root, or actually it's going to be 2 over 2 minus square root of 3 over 2 over 2 over 2 plus the square root of 3 over 2. This becomes 2 minus square root of 3 over 2 divided by 2 plus square root of 3 over 2. So then you have to do divide these two fractions, right? So then you have, this is equal to 2 minus square root of 3 over 2 times 2 over 2 plus square root of 3. This becomes equal to, so the 2 cancels out. You have 2 minus square root of 3 over 2 plus square root of 3. You can, if you want, rationalize the denominator. You're going to do 2 minus square root of 3 on top and bottom. This becomes 4 minus 2 square root 3. So, remember a minus b times a minus b is a squared minus 2ab plus b squared. This is going to be 4, so it's going to be 2 squared minus 2 times 2 square root 3 plus the square root of 3 squared. Like that. You can do FOIL method if you want. There's nothing wrong with that. And also, a plus b times a minus b is just a squared minus b squared. This is just going to be 2 squared minus the square root of 3 quantity squared. This becomes 4 minus 4 square root 3 plus 3, and then over 4 minus 3. This becomes, so we have 7, so 4 plus 3 minus 4 square root 3 over 1. This becomes 7 minus 4 square root 3. And this would be the tangent of 30 over 2, or tangent of 15, right, guys? So that is how you do half-angle identities. Obviously, you're going to do it, it depends on where your quadrant is, on what quadrant the angle falls in. So yeah, I mean, this is how you do half-angle identities. I do believe I did a video on double-angle identities. But yes, this is how you do half-angle identities. And the formulas, you have to kind of, I mean, I'm hoping that your professor or your teacher gives them to you, but you have to kind of, also, you have to kind of practice with them to see how they work. The way that I know whether or not it is positive or negative is by looking at my chart here. So, for example, or actually, I want to do one more example. So, so let's see, I want to do, one more example. So 45 over 2. I want to do 45 over 2. Just for the heck of it, because I really want to make sure that these are understood really well. So 45 over 2. So we have that actually, if you approximate it, so 45 over 2 is actually equal to 22.5. That falls in the okay, I see. Okay, well, give me a second, guys. So I'm gonna do one more example. This is gonna be the last example that I do on this video. So I'm gonna do sine of 105, cosine of 105, and tangent of 105. So sine of 105, cosine of 105, and tangent of 105. Let me actually color code this time. So I'm gonna do and then tangent, I'll do tangent of 105 degrees. So, and it should be degrees, by the way. So, 105 is actually, so if you multiply it by 2, it's actually 210. So sine of 105 degrees is equal to sine of 210 over 2, which is equal to, like I said, it was, because the way that I knew that was because you multiply, since you divide using half-angle identities, you divide it by 2, you have to multiply by whatever angle they give you by 2. So then that way you say, okay, sine of 210 over 2, cosine of 210 over 2, tangent of 210 over 2. That's how you do it, okay? That's another thing that I wanted to mention about this topic. Of course, 15 was easy because, of course, 30 over 2 is 15. But for 105, we have to multiply by 2 to find what, and even for the other one, again, if you would have, you know, because they wanted to know what sine of 15, cosine of 15, and tangent of 15 were. So then it was like, okay, well, multiply 15 by 2 to get the half angle, the theta part, over 2, right? So that's exactly what I'm doing. Or that's exactly what I did, rather. So then what you're gonna do is you're gonna go ahead and, so sine of 210 over 2, that's, going to be, so if you look at your half-angle identity, it's gonna be plus or minus 1 minus cosine of theta over 2. And we have to know the square root, actually. 1 minus cosine of 105 degrees over 2. But we have to know whether it's positive or negative. Looking at your sine chart, excuse me, 210 is, so we know that 210, so sine of theta over 2, 210 is actually, so the sine value is in quadrant 3. So that's negative y. So sine is negative there. So we can say negative the quantity 1 minus, and I believe that's how you do it, by the way. Give me a second, guys. Sorry, guys, I made a mistake. Oh my goodness. It's supposed to be, it's actually supposed to be, that's why I was getting it wrong. 1 minus cosine of 210 all over 2, not 105. Sorry about that, guys. So then you do, so then we know that sine in this quadrant is negative because if we go back to our chart here, sine is less than 0 when it's in quadrant 3. So it's going to be negative. It's going to be negative the square root of 1 minus, and the cosine of 210 is negative square root of 3 over 2. So it's going to be negative, so it's going to be 1 minus negative square root of 3. It's going to be negative square root of 3 over 2, all over 2. So then this becomes negative the square root of 1 plus square root of 3 over 2, all over 2. So then this becomes negative the square root of 2 plus the square root of 3 all over 2, over 2. So then this becomes negative the square root of 2 plus the square root of 3 over 2 divided by 2, which becomes negative the square root of 2 plus the square root of 3 over 2 times 1/2. This then becomes negative the square root of 2 plus the square root of 3 over 4. This then becomes negative the square root of 2 plus the square root of 3 over the square root of 4, which then becomes negative the square root of 2 plus the square root of 3 over 2. This is what sine of theta over 2 is. Now, what about cosine of theta over 2? This is the last problem, by the way, guys. I keep saying that because I feel like my video is getting a little bit long. It's going to be cosine of... So cosine, this is what sine of 105 is, by the way. Sine of 105. Now, what about cosine of 105? Cosine of 105 is equal to cosine of 210 over 2. So then this is going to be equal to, and if we look back at our formula, we know that cosine in quadrant 3 is negative, so it's going to be negative. It's going to be negative. Negative the square root of 1. It's going to be 1 plus cosine of theta all over 2. So it's going to be 1 plus cosine of 210 all over 2. Remember that because theta is 210. That's theta. Theta is 210. So let me actually do this so that you guys understand what I'm doing. So really this becomes negative the square root of negative the square root of 1 plus, and cosine of 210 is going to be negative square root of 3 over 2 again. So, but it's plus this time, so plus negative square root of 3 over 2 all over 2. So then this becomes negative the square root of 2 over 2 minus square root of 3 over 2 all over 2. This becomes negative the square root of 2 over 2 minus, so it's going to be 2 minus the square root of 3 all over 2. over 2. So then we do the same exact thing we did for the last one. It's going to be 2 minus square root of 3 over 2 divided by 2, which then becomes negative the square root of 2 minus square root of 3 over 2 times 1/2. This then becomes negative the square root of 2 minus square root of 3 over 2, actually over 4. So then this becomes negative the square root of 2 minus square root of 3 over 2. The way that I got that is I said negative the square root of 2 minus square root of 3 over the square root of 4, which becomes this, right? So this is what cosine of 2 theta, or cosine of theta over 2 is, excuse me. So now tangent of 2 theta, or tangent of theta over 2, oh my goodness. I keep confusing my double angle and half angle. So, this is going to be, like I said in the last problem, it's going to be equal to the square root of 1 minus cosine of theta over 1 plus cosine of theta. This becomes, so we know that tangent in quadrant 3 is actually going to be positive because negative y over negative x. So it's going to be positive the square root of 1, and we know what the cosine of 210 is. It's going to be 1 minus, so it's going to be 1 minus the negative square root of 3 over 2 over 2, or I'm sorry, over 1 minus square root of 3 over 2. So then this becomes the square root of 1 plus square root of 3 over 2 over 1 minus square root of 3 over 2. This then becomes equal to 1. So it's going to be equal to 2 over 2 plus square root of 3 over 2 over 2 over 2 minus the square root of 3 over 2. This is all square rooted. So then this becomes 2 plus the square root of 3 all over 2 over 2 minus square root of 3 all over 2. This then becomes 2 plus square root of 3 over 2 divided by 2 minus square root of 3 all over 2. And it's square rooted. So then this becomes 2 plus square root of 3 all over 2 times 2 over 2 minus square root of 3. This becomes 2 plus square root of 3 over 2 minus square root of 3. And to rationalize a denominator, just multiply by the conjugate. So 2 plus square root of 3 on top and bottom, because the conjugate of 2 minus square root 3 is 2 plus square root 3, right? So then this becomes 2 squared plus 2 square root 3 plus square root of 3 squared. So then, and then it becomes 2 squared on the bottom, 2 squared minus square root of 3 squared. The way that I got that again is a squared minus b squared equals a plus b times a minus b, and a plus b squared equals a squared plus 2ab plus b squared. So, in conclusion, this becomes 4 plus 2 square root 3 plus 3 over 4 minus 3. This becomes 7 plus 2 square root 3 over 1, which is equal to 7 plus 2 square root 3. And this is your final answer for this one. Okay, guys. So in reality, yes, these can be a little bit mind-boggling, but you have to understand, it's important to just understand this chart as well as to understand the formulas very well. My number one rule, guys, for every one of my videos is practice, 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 practice. And watch my videos, and any other videos as well, if you want to watch any other videos. The way that you know whether it's plus or minus is by looking at this chart. You have to know where sine, if sine is, you know, where your angle is in terms of the unit circle. So looking at the unit circle and looking at this chart is the way that is basically your go-to for these types of problems. So with that being said, guys, thank you so much for watching. If you guys have any questions, let me know. Please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.